genetic pedigrees. So go ahead and label your Cornell Notes pedigrees. And what pedigrees are basically is drawing a family history, family chart of as many people as you can think of, and then try and figure out what their genotypes are. And so basically the way it works is this, and you've probably seen these somewhat before. You use squares for males and use circles for females. So squares for male, and then females we're going to use circles. And remember, we can't see genotypes, all we can see is phenotypes. So for whatever trait you're looking at, if they have the trait, right, then you go ahead and you darken in. If they don't have the trait, then you keep it open. So for example, this square right here would be a male, right? Is that my male symbol there? A male who has the trait that I'm looking at, whatever the trait is. Maybe it's simply baldness I'm looking at, or maybe it's some sort of disease like cystic fibrosis. That's how you indicate it. You connect the two if they're mated together. So they're married here and they're having children. And what you do is you put them in generations. So, for example, let's look at what's right here. This is the first generation. That's dad there and that's mom. And they're mated together. And then you go down a generation. Now we're in generation 2. These are the children here. And that's their daughter. And that's their son. And because all of the circles and squares are open here, we are indicating that nobody has the trait that we're looking at. We're not going to get into complicated stuff like that. That's basically how you do it. And the odds are that you can't tell 100%. Remember, genetics is all about probability, so I never know for sure what's going on here. So the more people that you can put into the family tree, the more information you get. Remember last time I talked about how geneticists always like to use animals and plants that have a lot of offspring, a lot of kids, or what we call progeny. That's easy if it's, mice or if it's fruit flies, but what do you do with people? I mean, people don't have 100 kids most of the time, right? So the way you do it is you try and put more individuals into a pedigree, not individuals from one mating, but see if they're all related. Okay, let's take a look. So here's an example. We don't have to write this down here. You can see that there are 3 generations here, right? So there's the grandkids, there's the parents, there's the grandparents up here. You can see that they're married, right? So I would say, okay, I'll start off here, XY, and that's XX. It's always got to be like that, right? And these guys here, they have whatever the trait is that I'm looking at, right? Now, if you see that the trait occurs in a single generation, we would say that the gene for this trait is probably dominant. Now, I can't be 100% sure, and there's not a lot of people in here, but that's my best guess. So if you look at this one here again, every generation, it's probably a dominant trait. In this case, I was looking at Huntington's disease. Now, this one doesn't fall in every generation. See, this generation right here, nobody's got it, right? So since it skips a generation, right, I would assume, so there's XY, that this might be a recessive trait, right? That's my best guess. Don't know for sure, but that's my guess. Cystic fibrosis, for example, is a recessive disease. Okay, now here's the other thing. Now we got to determine, so we know if it's dominant or recessive by looking at if it's in every generation. Our next guess is it a autosomal, that is a gene which occurs on chromosomes 1 through 22, or is it on the 23rd pair, the sex one? So here we go, XY, XX, right? Now you can see that it occurs not in generation 1, but it does occur in generation 2 and 3. So we're going to guess that this is recessive, right? That's my best guess. Then the next thing is, if it pretty much occurs in boys, we would assume it's sex-linked, because remember, the odds of it occurring in boys is much greater because they only have one X, whereas girls have 2 X's. And you can see boy, 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 boy. My best guess here is that this trait is recessive and it's sex-linked. Okay, so what does a genetic counselor do? They try and get as much information. They do a pedigree of your family, and then they make their best guess. You can never be 100% sure, but the more people, the more accurate the guess is going